Welcome to Digital 360 Summit 2020. We are the premier event for senior executives driving industry digitalization, decentralization, and decarbonization. 2020 edition is a free virtual event via Zoom. The dates are August 18th, 19th, and 20th, 2020, and August 25th, 26th, 27th, 2020. We want to thank our sponsors, Texas State University, Greater San Marcos Partnership, and Cedar. This year's edition has 70 speakers from amazing companies like NASA, Intel, SAP, CPS Energy, Brazos River Authority, Katera, Direct Energy, City of Austin, Aclara, Dell, Engie, Exelon, Oracle, Test Truck, General Motors, TXDOT, Vistra, Siemens, AT&T, National Grid, Itron, City of Los Angeles, Austin Energy, City of Colorado Springs, and Hunt Energy Network, and over 1,000 attendees. The program has 16 keynotes and 11 panels, followed by 11 white papers and 28 videos. The event covers multiple industry verticals like networks, energy and utilities, buildings and infrastructure, water and wastewater, public safety and new financial tools, smart cities, sensor and edge computing, big data and software, smart mobility, new regulations and business models, space and smart factory, and Industry 4.0. We are also introducing Texas State Cedar, a new industry research consortium focused on connected infrastructure research enabling big ideas and the topics covered in each of the panels. We at Texas State, Star Park, Cedar, the Greater San Marcos Partnership, and industry partners are focusing on building 9 living labs to transform applied research and economic development with the goal to delivering one digital world.
Welcome. How exciting is this? Unbelievable. Our 6th day of the Digital 360 Summit is our last session of the day and probably the most exciting session. Keep the best for last. And we have a phenomenal STEAM panel and a great keynote. Before I introduce you to your keynote speaker, I want to share a little more about the Cedar Consortium that was introduced in the prior panel. In the prior video. And so let me share this screen with you real quick. Hopefully you can see that. And let me make it bigger. And if you can turn your volume up, it's very loud. This is a quiet video. It's a short video about Cedar, and here we go. Excellent. Well, thank you for being here again. And the audience is coming in, and usually it takes a few minutes for them to log on. But we have a phenomenal program for you in this session. Let me cut to the chase and introduce our keynote speaker, George Salazar. How are you, George?
I'm fine, thank you.
Excellent. George is a significant player in the space world. He works at NASA, and he is the human-computer interfaces chief engineer and leader. And he can tell us more in detail about all the things that he does and has done. But we're very excited that he's here. As space has been reinvigorated lately, especially with the SpaceX rockets that land backwards and all the things that are going on with the space station. And I can't wait to hear from George about his keynote and maybe how we're going to get to Mars. So George, take it away, and I'll run your slides for you, and I'll go and share my screen. And so it's all yours.
All right, thank you, Andres, and thanks to the 360 Summit for inviting me to be a keynote speaker here. So over the past several sessions, I've listened to some of them, and there's been discussions about digital transformation, smart sensors, data analytics, smart cities, challenges such as cybersecurity that I've listened to. And so I feel somewhat of a little bit of an oddball keynote speaker here, but at the same time, I have to say that both the terrestrial systems that I've listened to, as well as the space systems that I'm involved with, we both share the same goals. We share the goals of cost reduction and increased resilience and reliability of products and systems. For example, cybersecurity. Obviously, that's a big issue. That's a big issue in today's times. So for NASA, we see the importance of digital transformation to be successful in competing and basically completing our future missions to be efficiently and effectively. So my talk today will provide you with an awareness of what's going on with NASA, and also associated with digital transformation is NASA's leadership in pursuit of digital transformation and some of the challenges NASA faces as human spaceflight missions are going deeper into space. Next slide, please. So here's the topics that I plan to cover today, and it's basically the planned mission to Moon, as well as going to Mars, and then we'll spend most of my time in the area of the need for digital transformation for future deep space human missions, as well as some parting conclusion remarks. Next slide, please. So the Artemis program is basically very similar to the Apollo space program. In fact, Artemis was the twin sister of Apollo. And so the Artemis program is basically returning back to the moon. And in order to do that, there's a lot of methodical things that have to happen in order for that to, in order to make that a realization. So can you click, please? So the first thing that has to happen is that we first have a human spacecraft to the moon in the 21st century. There's going to be an unmanned spacecraft. Basically, it's the Orion spacecraft that's going to orbit the moon for about 21 days to make an assessment of the systems that have been designed for the moon mission. One thing that I want to point out, and I'm going to be mentioning this again in my presentation, is the radiation effects associated with electronics in deep space missions. Much different than the radiation environment on low Earth orbit associated with some of the stuff that's going on with space station. So I'll be mentioning that later on in my presentation. Next click, please. So the next thing is going to be the first humans to orbit the moon in the 21st century. And so this is going to be an opportunity to basically return humans to the moon, not necessarily to land them. That's going to happen later, but it's going to be now an opportunity to see how the Orion spacecraft is designed for the human missions, and having humans in place for the first time since back to Apollo program. Next click, please. And one of the first early deliveries, if you will, of payloads in the orbiting of on the moon rather, is going to be the solar electric propulsion system, which basically is going to provide propulsion system for the next click, please. It's going to be the pressurized module of Gateway. Gateway is going to be basically the equivalent of the space station that we currently are familiar with orbiting right now 260 nautical miles above the Earth. Next click, please. Next thing is going to be the human landing system delivered to Gateway. We're looking at this at about 2023. So the human landing system, in fact, that's what one of the things I'm involved with right now with commercial partners, is looking at possibilities of what kind of systems are going to be needed for a human landing system. Certainly, if you recall from looking at some of the Apollo 11 videos and Neil Armstrong landing I think it was the Eagle. The Eagle was the human lander back in the Apollo program, and so we're looking at options of how we're going to develop human landers for our future space missions. Next click, please. And then finally, crew missions to Gateway and to the lunar surface. So this is going to be now the opportunity around 2024 to land humans on the surface. And if we're looking down at the bottom, we're now looking at some of the opportunities that are going to be happening on the lunar surface. So one of the first ones is going to be obviously some of the early investigations of the early South Pole. That's where we're planning to land. That's where we're planning to explore. One of the reasons for that is because there's potentially some resources there that could help us look at what we call in situ resource utilization, basically living off the land, taking soil and extracting from that oxygen, and as well as fuel for our spacecraft. So next click, please. And also, we're looking at things like, for example, the rovers. Okay, where rovers are going to be very critical. They're going to be either autonomous or they're going to be controlled by humans. And we're looking at large cargo landers, and this is going to be the commercial space market is going to be instrumental in helping us develop some of these large cargo lunar landers. And next click, please. And we're also, one more click, please. And we're also looking at finally humans landing on the moon. We're going to have infrastructure in place. We're going to have the habitability. We're going to have habitats in there. We're going to have in situ. We're going to have astronauts doing extra vehicle activities, investigating all the possibilities on the moon. And this is important because the moon is going to be the proving ground. Right now, we're doing space station. Space station is Earth reliant. It's basically the opportunity to learn about living and working in space. But the real driver is going to be what we learn and what do we develop on the moon, and that's what we call the proving ground. And then on to Mars, which is going to be later in the late 20s, more so in the late 30s, 2030 timeframe. Next slide, please. So deep space mission operations. Next slide, please. So currently, we have space station that we've seen many videos and television reports about space station. Next clip, please. And what does that take to support that? It takes a huge number of people. It takes over 100 people. We've got Mission Control Center, which we call the flight controllers. But associated with those flight controllers, in a back room, we have what we call mission evaluation room, made up of subsystems engineers that understand the systems very well on the space station. And then we also have Moscow, which obviously is one of our partners with the International Space Station. I have to say that space station is quite a complex system, over 350,000 sensors, over 100 computers, but you cannot have just 3 astronauts or 6 astronauts that we currently have on space station, depending on availability of astronauts, for monitoring such a complex system. And so you have people on the ground doing a lot of that, let's call them the ears and eyes of the astronauts, monitoring all those kind of systems. So let's go to the Artemis program in the future. In a notional session, we're going to have the Gateway program. Next click, please. So we're going to have basically what we have right now. One of the things that's interesting is the time delay, and I'm going to be talking about that later on, is that it's only about 1.2 seconds one way going to moon as far as communication is concerned. And so we're looking at about 2.4 seconds round trip delay going from the moon to Earth. And that's not going to be the case for Mars, as I'll mention later in my presentation. Next click, please. So in the going to Mars, we're going to have a longer time delay that we cannot afford in case of a critical situation. And so we're going to be talking about an onboard mission control center. Basically, it's machine learning, artificial intelligence. One of the challenges of that, obviously, that's one of the things about digital transformation that's being looked at or being done right now as far as digital transformation on terrestrial systems. It's a little bit more challenging in deep space operations because in the let's call it in the space systems engineering application world, we do verification of systems. Verification, I mean, did we build the system right, as well as validation, did we build the right system? We do that most so with deterministic systems. And that's one of the things that's going to be changing for us in deep space missions. The determinism is going to change because of machine learning and artificial intelligence. These systems are going to be evolving over time. So how does one um, do verification and validation with a system that's continuously changing and continuously evolving? And that's one of the challenges, at least for NASA, for some of our future space missions. Next click, please. So we're going from a crew mission control dependent system as it exists right now to a crew vehicle dependent time system in the future. Next slide, please. So let's now talk about the need for digital transformation for future deep space human missions. And next click, please. So the history of digital transformation for NASA is quite interesting because next click, please. You look at NASA as far as how it has used digital transformation back in the 60s and 70s. And so if you think, next click, please, about the Apollo space program, and more so Apollo 11. Next click, please. Apollo 11 had a digital twin, so to speak, on the ground. And if you're looking at that top picture of there, that's basically one of the simulators that was used for Apollo 11. And the interesting thing about this is during Apollo 11, there was a gentleman that was involved with some of the early, let's call it mission simulations by the name of Stephen Valles. And he noticed that the what was called the alarm 1201 code was basically a warning and not necessarily a critical error. And this is important because if you recall, if you ever seen the Apollo 11 documentary or any of the pictures or motion pictures associated with Apollo 11, it basically implied that there was a critical event, but it really wasn't. And because of the some of the simulation done in what was called basically a digital twin at that time, they found out that the 1201 alarm was more of a caution. And if it not had been for the gentleman, Stephen Valles, he and not putting that into the procedures, they would have aborted Apollo 11 and we would not have landed on the moon. The next click, please. So same thing, similar to Apollo 13. We had a digital twin. If you saw Apollo 13 with Tom Hanks, you know, they talked about, you know, simulation of on the ground about power conservation and all that. Well, that happened in Apollo 10. During Apollo 10, they ran a simulation during one of their trainings of what happens of the failure of the lunar module and the lunar, rather the command module, and what would happen if the lunar module was the, let's call it the lifeboat. And so that scenario was written into procedures, and lo and behold, during the Apollo 13, it turned out to be very beneficial because they were able to use those procedures and the many of the something like 13 simulators on the ground to configure rapidly for a digital twin to figure out what's the best possibility of shutting down systems and conserving power. So next slide, please. And we've done that on shuttle and station. Next slide, please. Rather, next click, please. Shuttle Avionics Integration Lab, same thing. You know, we had that for the space shuttle. Next click, please. Same thing for space station. So one of the key things that we found about digital twins for the space program is that from a standpoint of key drivers or let's call them requirements, is that it should be connected. Digital twins require constant feedback of data from the physical asset that can be used to update their connectivity, their connectionness, to inform engineering decisions. Adaptability. Digital twins need to be flexible enough to react to changes in physical assets. Contemporary digital twins consist of multiple interacting modules that can be combined to account for different aspects of performance. So for at least for the space program, we look at different types of simulation models and then collectively combining them together for configuring. Sometimes it's called systems of systems engineering to figure out what's needed in order to solve the problem. And certainly, last but not least, is responsiveness. How fast can we respond to a critical event? Next slide, please. So next click, please. So what's NASA initiative to embrace digital transformation? Well, one of the things that we had to recognize is missions are increasingly complex and integrated with industry and on shorter timelines. Right now, I am involved with some of the commercial partners, SpaceX, as well as the Boeing commercial sector of spaceflight. And I'm seeing quite a difference as far as how they're implementing some of the tools for model-based systems engineering and other tools as well. Next slide, please, or click, please. Aerospace industry and the world is digitally transforming around us. Next click, please. The other thing is technology convergence, machine learning, AI, model-based systems engineering, high-performance computing, integrated multidisciplinary modeling and simulation are also coming on board, and we need to understand that and how we're going to incorporate that into our NASA engineering processes. Next slide, please. Top talent. This is important. Top talent, expecting to work in a digitally enabled workplace. And so you got tools, you got processes, and then you got people. And basically those three, for the most part, comprise, let's call the framework of a process, or let's say, for example, digital transformation or systems engineering. I have to say that it's the people that make things happen. That you can have the best tools in the world, the best processes in the world, but if you don't have a very technically savvy workforce, it's not going to work. Next click, please. And also enable integrated universal collaboration with partners. We need to get on board with the partnership and what their capabilities are and integrate that into the NASA framework. Next slide, please. And that's going to provide new NASA opportunities and enhance mission impact by reinventing its processes, products, and capabilities. Next slide, please. So let's talk about some deep space mission challenges notionally. And so what you're seeing on the left is basically the human element, which is very important for NASA, and then the technology. So let's kind of briefly click through these and understand. Obviously, human needs water. Next click, please. They need air to breathe. Next click, please. Food. Next click, please. They got to have sunshine. Exercise because of the lack of the gravity, isolation, that's a big one. Radiation effects on the human element. This does now address technology. Looking at in order to address the isolation is to have things like telepresence. Looking at that next slide is associated with power generation. In situ resolarization, living off the land. Next click, please. Also looking at telemedicine. Astronauts are going to get sick. They're going to get injured. How are we going to deal with telemedicine when they're far, far away? Next click, please. And also, that's a prototype of environmental life support systems for generating oxygen. Next click, please. As well as reentry, descent, and landing of huge spacecrafts on Mars, and it's a major challenge trying to land huge payloads on Mars as compared to the Mars Science Laboratory. And now the one that's going to land sometime in a few months is going to be the Mars 2020. And then, of course, next click, please, is the radiation effects on electronics. Next slide, please. So the need for digital transformation. Mars is a complex paradigm in mission complexity. Right there, I'm showing you that the more interaction you have in the elements, the more complexity is involved in the verification of these elements. Next click, please. And so what you're seeing here on the right-hand side is NASA systems engineering process. NASA systems engineering is very critical for developing these complex systems. And without systems engineering, it's very difficult to basically deal with complexity of complex systems. Things like digital transformation, smart cities, things of that sort. You got to have a systems engineering process in place to improve the mission success against risk. There's risk always in a program, and NASA values that as well. What you're looking down there at the bottom is the barriers associated with human error. These barriers are basically processes in place, but they're not perfect. There's holes in the system, and those holes sometimes will line up to create the hazard. And it's one of the things that we have to be aware of is to understand how we can mitigate some of those hazards. Next click, please. The human systems integration, critical to mission success. Next click, please. So you got the what we call the human systems integration, HSI. And so we're looking at the mission effects on the human element associated with safety, associated with operations of the system, associated with training, maintenance, and supportability, habitability, and obviously the key factor in human systems integration is human factors engineering. And these are the guys that basically ensure that the system factors both the limitations and also the abilities of the human in operating some of these complex systems. There's a high likelihood that not all scenarios are going to be incorporated, and that's where the digital twin will come into effect. Next click, please. So let's look at one of the major challenges, ground systems. I'm just going to give you a notional look at ground systems. You got internet, Internet of Things, cloud computing. Next click, please. You got high performance servers. These are high computing platforms. You got server farms. These are huge rooms with a high performance computing power. And associated with that, next click, please, is large space power availability. You got processor speed and gigahertz range operation. So let's contrast that with space operations from a cloud computing standpoint. Next click, please. You're looking at the radiation effects, because the radiation effects, we have to deal with certain types of electronics design that basically, next click, please, limits us to performance and computing capabilities. These radiation-hardened, radiation-tolerant computer systems are slow and very expensive, but they can handle the deep space environment. And so what you're looking at on the right-hand side is basically what a server farmer looks like, which is very small. Size, weight, and power are a premium. Next click, please. As well as processor speed is in a low megahertz range. Next click, please. All right, so digital twins, challenge number 2. Next click, please. Next click, please. And one more. All right, so basically what I'm trying to show here is that in the virtual space on the left-hand side and the physical space, we have a lot of data going back and forth, making an assessment of the physical space based on the and the virtual space, taking that data and analyzing it to see have things changed from what we've done ground verification and validation. But the distance is very long. You know, we're talking about minutes. We're talking about 20 to 30 minutes for round trip delay. Also, the data rates are very slow. At this point in time, with the best we can do is 3 to 4 megabits per second. We're looking at laser technology that'll increase it tenfold, but still tenfold in communications is still somewhat of a challenge in trying to update a virtual space with a physical space, especially if you're including the human, which is non-deterministic. Both hardware and software, as well as the environment, is deterministic. The human is not. And so I always tell folks that the four elements you always have to consider: hardware, software, the environment, and the human. The human is the only one that's non-deterministic, which is a little bit more challenging. Next click, please. So in conclusion, next click, please. One click, another click. Developing technology to learn to live in other worlds. That's what we're doing right now. We need to refine the digital transformation process. Next click, please. And next click. And so we're going to eventually settle on Mars. Next click, please. We're going to be continuing to refine the digital transformation, the virtual environment, the digital twin, if you will. And then one day, next click, please, we'll be going on to other worlds. Next click, please. All right, that concludes my presentation.
Wow, 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 George. That's amazing. What a setup. Incredible. I wonder if we before we swap to the audience, I'm wondering if any of this illustrious faculty and superstars in smart factories and Industry 4.0. Does anybody have a question for George? Anybody curious to know anything about what he has shared? Anyone?
George, this is outstanding presentation, and my question is the digital twins, creating digital twins with the at the Earth, right? Have different conditions than what you would experience in Mars or the Moon. So how do we collect the data to enable an accurate digital twin?
Okay, so that's a good question. So initially, we're going to have to, for the lack of a better term, buffer a lot of data. We're going to have to collect data with the not only the environment, but also we're going to have to, I guess, for the lack of a better term, do an initialization of a lot of the hardware and software. And so what we're going to have to first initially do when we first land a lot of our assets on the moon. And certainly more, the moon is going to be our proving ground. The moon is going to be basically determining how we're going to do digital twins on Mars. And so the scenario is that once these assets, if you will, the human lander or rovers or what have you, they're first going to transmit the status of the information, the health of their information, and all this. This is going to be feeding back to our ground, let's call them our digital twins. And then those digital twins in turn are going to be updating their models. We are not going to be able to model every possible condition that's going to occur on the moon as well as Mars. You know, they say, well, we've been to the moon, been there, done that. Well, you know, guess what? A total time of 13 days is all we've been on the moon for. And so right now we're going back to the moon to stay. And so 13 days is just a drop in the bucket. So we're going to have to learn how to develop these systems to transmit a lot of information initially to basically update the models and say, oh my gosh, you know, I didn't factor this into the model. And so all this information is going to update the model, make it a little bit more robust, and then from there, there's going to be perhaps a, let's call it a sampling rate. Let's call it a digital twin sampling rate of data that's being transmitted to the ground digital twins to update this information. Of criticality, at least importance to a lot of us here at the Johnson Space Center, is the need to assess the human element, because one of the things that we have no clue about, even though we've done a lot of studies about isolation, we are still not sure how the human is going to behave in deep space. And a human that has physiological and psychological issues could make for a likelihood of a hazard occurring because of the human interface failure to take into consideration a design that does not mitigate a inadvertent command that could cause a hazard.
Wow.
Hey, George.
Go ahead.
This is John Dwyer. I have a question for you. In something that's a project that spans over a couple of decades, how do you plan for when you're looking at decentralized computing power, some of the things you showed on the slide, how do you plan for the progression of technology and hardware and communications over those period of years to take advantage of what's available? Like what's your time frame when you can implement something into the system versus being outdated with, as fast as technology is advancing?
Oh, that's a great question. One of the things that we're challenged with right now, in fact, my group is involved with, is graphics processing units. And so, we take for granted, the GPUs, the graphics processing associated with ground terrestrial systems, simulating complex engines and things of that sort. But in deep space, GPUs will not work as the commercial GPUs as we know them right now will not work in deep space. We took some GPUs. We took 5 GPUs to Indiana University and bombarded them with radiation, and we couldn't even get them to start operating before they started to they freeze up on us. And so one of the things that we're looking at right now is rolling your own GPUs using radiation hardened type technology, and as well as looking at some of the commercial graphics processing software, like for example OpenGL and Open Safety Critical software, and incorporating that into some of the processors that are radiation hardened, radiation tolerant, particularly ARM processors with GPUs in them. And so that's one of the investigations that we're looking at. We've currently engaged SHREC, which is the consortium out of Pittsburgh, I believe it's Pittsburgh University, that deals with deep space high performance computing. And so we have a couple of PhD students working with us in that. So what we're trying to do right now is make an assessment of what kind of computing technology is going to be required and developing requirements, because one of the things that's missing, NASA's kind of big on requirements, and so one of the things that's missing is what kind of requirements do we need for GPU processing in deep space, and because again, size, weight, and power are a premium for deep space applications, and so the time frame for that is kind of like TBD right now. We're looking at what kind of technology is in existence right now. Where do we need to go in order to incorporate machine learning? How much machine learning do we need for a complex vehicle spacecraft going to Mars, as well as habitats on the moon? And then and looking at what is it going to take to develop that kind of technology. We've tried to elicit the support of NVIDIA and some of these guys that have general purpose GPUs, but even though they're interested in the space program, their business model is not into developing radiation hardened graphics processing units, because obviously they're more into gaming than they are into deep space. So that's one of our challenges is to see how we can get there.
Awesome. I'm gonna pause you, George. Please stick around with us, and if there are any questions from the audience, I'm gonna encourage you. Let me switch gears, and Jesus, you're gonna take 60 minutes from the moment you start talking. So don't worry about the 4:30, the 5:30 time frame. Let's go over all the way to 5:45. So Dr. Jesus Jimenez, we're lucky to have him today to moderate this amazing panel. And thank you again to George for sharing this amazing keynote to tee things up on Smart Factory and Industry 4.0. George is the director of the Ingram School of Engineering, and we are delighted to have him. And George, to take it away, is your panel. Again, go all the way to 5:45. Have fun.
Thank you, Andres. Thank you for the introductions. And I would like to thank Digital 360 Summit for the opportunity to speak about this important topic. First, let me introduce the panel that we have today. We have outstanding members, panelists today. First of all, I have Franco Heijningen. He joined us he's Vice President of Strategic Operations in CREAN Incorporated, and he has a lot of experience in facility management, IT, security, engineering, construction, and manufacturing. I also have Dr. Tone Lerher, and he joined us from Slovenia, from the University of Maribor. So thank you, Tone. I know this is already very late for you, so I appreciate the efforts. He's also doing his research in intralogistics, and he's current member of the College Industry Council for Material Handling Education. I also have Dr. Damian Valles. He's an assistant professor of electrical engineering at the Ingram School of Engineering. And he has a lot of experience in machine learning. Also, we have Michael Raiford. Michael Raiford, he has a lot of experience in the semiconductor manufacturing industry, working for Samsung Austin Semiconductors. He is currently, he started his consulting business where he provides services in Industry 4.0 and smart manufacturing. We also have John Dwyer, and John is a principal and senior consultant at CMG Consulting LLC, and his business strategy and operational design, also expert in product and process technologies, project management, smart buildings, property technologies, wearable technologies, and connected technologies. So thank you everyone for joining the panel. I appreciate all these, all the expertise that you have to share here. Let me just quickly explain to the audience. We're going to have each of our panelists give a quick introductions about themselves and kind of give us a position of what smart manufacturing means. And let me start with this question so that they can provide us part of their participation. How are the new technologies such as artificial intelligence, augmented reality, Internet of Things changing the manufacturing industries? So let's start with Franco.
Yes, good afternoon. Thank you very much for inviting me to this panel. So we believe that with CREAN that the most important thing that's it's changing by influencing smart manufacturing via artificial intelligence, IoT, augmented reality, and virtual reality is the human aspect of it. As George has talked about it himself earlier, the human is going to play a more and more important role in the future, even as technology becomes a bigger part. It is our opinion, we are a technology integrator, but we always start with integrating people with processes and technology and making sure that the people that your manufacturing solution work with are set to be successful. you need to make sure that the skill set is where it needs to be, and that the mindset is where it needs to be. And I'm not just talking about the people that use it, the technology. I'm talking about everybody from top to bottom need to have the right mindset in order to make sure that the processes that you're developed and changed, as well as the technology that you're going to introduce, is going to be effective. I always say that if I give my 2-year-old niece the keys to my car and she can't start it, doesn't make it a bad car. It's just the wrong combination. And that really is something that we think about all the time. How do we find the right balance between the right people and the right processes and technology? So.
Thank you, Franco. Michael.
Okay, so thanks for having me also, and going after Franco and talking about people is a big part. Coming out of the semiconductor industry, where we're already fairly highly automated on a lot of tools on the floor, the changes that we're kind of seeing is a whole lot more focus on moving machine language type stuff, learning out to the tools in real time. And how are you going to manage that? How are you going to build those systems? How the equipment going to respond? So we spent a lot of time. Challenges around that is learning your data and stuff. I started 2 years ago at Samsung working on this. We would collect something like 50 million parameters a second. Totally unusable, right? So we spent a year cleaning that up to get down to maybe 20 parameters collected every second, and then started building systems. And so what we're seeing, the changes on the floor, we would have to use metrology tools to measure the output of the equipment. In semiconductor, you can't really tell. But using some of the parameters and machine learning, we can now predict the output without having to measure it on that tool, which saves you that tool, allows you to come back and change the processing real time, feed forward, feedback systems. The challenge there in the factory floor is now your engineers have to be really, really good and on top of what they're doing and understand it, because one mistake can cost you thousands of wafers in a matter of hours. So, you know, how are you going to make sure that people are managing those in real time, making them work? The other challenge we found as you move it out onto the factory floor is how do you hook up a lot of this stuff too, which may come up again later, is if you didn't put in the infrastructure in the first place, you need a lot of edge computing. It's not there. It's very expensive. So how in the future is that going to be built in? You know, is it going to be 5G, private networks, some other sort of connection, which then opens up, I heard earlier, with the cybersecurity. So we found we were having to teach our engineers, people on the floor, you know, not only do you need to understand data and how your systems are running, you got to understand how to keep them safe. So it's really going to change for the engineers in the factories. It's going to allow a lot of real-time processing, improve quality, but it's going to put a lot of pressure on the engineers to keep that system working and in prime condition.
Thank you, Michael. Tony, what is your perspective?
Yes, thank you, Jesus, for inviting me here. Yes, so especially in the Europe, where this Industry 4.0 has been coined by the German government, you know, so there is a huge potential of the IoT, you know, which is actually which is the physical objects embedded with electronic sensors and software, and the network which enables the object to collect data and exchange data. And then there is artificial intelligence and augmented reality, which is mainly which is used for the maintenance, for example, in the mechanical engineering. So there is, I believe there is a huge advantage of this technology. And of course, I believe that there is, from my perspective, from my laboratory, we have developed, as you know, a sensor for measuring the humidity and the temperature. And that there was quite quite challenging, this development, because when you're developing such sensors, then you need to develop as well the application for, so that you can gather the data from the sensor to the cloud. And then as well, there is a problem for data analytics of those information that are stored in the cloud. So we are struggling with IoT in our laboratory, and working closely with the industry to show them our application of the IoT in intralogistics. Yeah.
Thank you, Tony. Damian.
Well, thank you for having me as well. You know, thinking about the manufacturing implementation of all these technologies definitely helps to have the involvement of not just faculty and researchers and industry partners working on this. It's also the fact that we can have students working on this. And one of the best ways to start implementing such technologies like IoT, AI, and augmented reality and visual capacity is that we can have students be exposed to it in order, when they do arrive to industry and they do have a job and they have to perform these tests as engineers, the development of such solutions becomes part of the design from the beginning and not part of the solution when everything's more complex. And I think that it will enable the innovation of any industry, including manufacturing, and how organizations can easily and more reliably adapt to the implementation of these technologies. I think the important part of it is that that's going to also increase the innovation and the need to critically change and adapt to new technologies as they keep evolving. So the education, not just of the engineer, as you also have to train the engineer, but also expose to them as early as possible, not just through what kind of job they have, but based on also the type of education they get earlier on in order for them to adapt to such technologies and ideas. And I think at Texas State, we've been doing, I feel, a great service to the student in trying to develop curriculums that are spawning from our engineering programs and our Ingram School of Engineering to do the same mission of being more data enabled and more data concentrated in how that plays out into engineering designs. And so we're working into helping the engineers of the future be able to more easily adapt these technologies and create them. It's not just smart manufacturing, but enable data for all industry.
Excellent, Damian. Thank you. John?
This is again, thanks for having me as well. And I guess I'm going to break that into, I think it's a potential for impact and build off of what these guys said in three areas. You know, the first one, I think Michael was talking about speed, and we were talking about, you know, decentralizing decision-making, whether that decision-making is automated or whether it's information you get in front of a person. You know, at more of a discrete level, the movement here from like industry 3.0 to 4.0 is, you know, from having advanced technologies and computing on the factory floor and automation, it's the data and the intelligence around there to make these decentralized decisions much faster. So I think, you know, when you increase that, you increase speed, you increase quality, you know, from a perspective of let's say in a factory environment. I think the second big impact is something that also came up. It's the collaboration and a change. I think Damian was referring to this. When we look at developing products today, and you look at, you know, DFX, design for cost, design for quality, you're going to have to start having the front end design for all of this data analytics and data management, because, you know, one of the keys is when you start to gather this data and information and you're analyzing it, what is the time sync to when you can trust that data, to when you can make those decisions. And to me, some of that goes back to product development and product design, of being able to, when you're going to implement that product and you're going to have these advanced technologies down the supply line, how you're designing for that. And then I think the third big impact is progressive leaders are going to see that maybe the ROI on technology investments is going to change from what has traditionally happened to understanding that with AI and with advanced data, it's a continuous evolution. And so, I think some of those models, we're going to see more progressive leadership change, which will allow us to maybe look at different type of ROI or different type of return on those investments. And, and that could vary a lot across industries and philosophies and companies and things. But I think that's a third area that we can see significant impact.
Thank you, John. I have one question for George. So we have learned a lot of the technologies from the space exploration research. A lot of the manufacturing companies, they have been able to deploy those technologies into their own systems and become productive. So what kind of partnerships do you form with industries to, share the technology, such as digital twinning and those kinds of elements, George?
Okay, could you repeat the question, please?
Yes, the question is, typically we learn a lot from the space exploration research conducted by NASA and other enterprises. And they typically lead the way in these developments, and later manufacturing companies adopt that technology. So how do we build those partnerships with these the space exploration and NASA, so that we learn what you guys are doing in that space?
Okay, so the partnerships have already started with the Commercial Crew Program, and SpaceX, Sierra Nevada, Blue Origin, Boeing, and all these commercial companies that are pursuing commercial space. And so what we're trying to add, so to speak, is especially for human spaceflight, not so much for unmanned spaceflight, but human spaceflight, is again factoring the human element into design of systems, as well as the certification process associated with certifying a system for human spaceflight. And so I can't give you specific examples, but one particular entity that I won't mention, they've basically taken a lot of our processes and looked at them and said, here's some recommendations for basically making this a little bit more efficient and effective. And so we look at it from the standpoint of, yeah, it's efficient and effective, but it's also safe. So there's actually three aspects to it. We're looking at the safety aspect of it, because the safety of the crew is always important. And once you launch, it's you better have gotten it right once you've launched. And so we try to interject the years of experience that we've dealt with as far as human spaceflight and certification of systems for the use of where you have humans in the loop. So that process is going on, but I have to say that where the commercial partners are ahead of us is in the area of digital transformation and using a lot of digital data and digitizing a lot of data for a lot of their model-based systems engineering, for a lot of their simulations. The ones they still challenge with is the human, as I mentioned earlier in my presentation, that deterministic hardware and deterministic software, for the most part, as well as the environment, is pretty much, we understand that. What we don't understand is the human and how it changes over over a day, from day to day. So, but I think NASA's contribution is to interject into the commercial process what it takes to build a human-rated system. But the commercial partners basically are taking a lot of that and saying, okay, we got these processes in place, and help us make sure that we are factoring all the aspects that NASA needs for a safety critical system.
Thank you, George. Excellent. So, as I have had the opportunity to visit several manufacturing companies, I found that some of them they're not ready to deploy Industry 4.0 smart manufacturing concepts. There are several motivations. Possibly one of them is the return of investment is not there. So, my question to the panel is, what kind of changes inside the facility or in the organization are needed in order to enable smart manufacturing environments? And before we answer that question, let me connect this to another question that I have from the audience, which is, how do we make sure that Industry 4.0 can be done at the edge versus in the cloud? Which one is better? Should we do it at the edge or in the cloud? What are your thoughts on these two questions?
I think it depends. I don't think either solution has one certain standard by which a certain manufacturing or Industry 4.0 process will benefit. I think the evaluation of what you're trying to do with Industry 4.0 should lead you to either pick one solution versus the other or a combination of both. I think the cloud is definitely a place in where you do need to handle quite a bit of computation and data. That means you have a large manufacturing plant and you have overloaded of a lot of data telemetry that you have to handle. The edge depends on what type of controls you want to have nearby. So the development of ideas on which solution to use is going to depend on the implementation of the process itself, the interactions of the operators or the lack thereof, and what exactly you're trying to do with the data. I don't think, those are very vague answers, but those are questions that need specific answers in order to ideally know what exactly you can implement.
Thank you, Damian.
I think, Jesus, to build upon that, the depends part, put a little more context and then maybe a couple examples. I think that relative to the part of the question is for whether the edge or whether the cloud, I can see where that is a combination of a technical answer and an economic answer, and it could change over time depending on where the cost and requirements are for processing power. But you've also seen where there are a couple applications we're currently working with where it's like with video processing, you need the power and the speed of coming back from the cloud isn't quite there yet to where you could, need to have that power centralized. And I've also seen hybrid solutions where, like in camera system for monitoring, where there's information for AI going to the cloud, but once enough data from all the different users is creating rules, it's getting sent back into the local processing. So that's to me, it's a bit of a potential for that to evolve as well, but I don't know if it's either or.
Thank you, John.
Yeah, I'll talk a little bit from the semiconductor side, what we're seeing, maybe cloud versus edge for different reason. With all the equipment, who owns the equipment and which parts of it. In semiconductor, the vendors still own part of that equipment and data, and they don't want to share. As we go into Industry 4.0, everybody thinks that data is going to be worth something. So we've seen where we have the vendor who's collecting some data, we're collecting some data, we're trying to generate other data, and you can't get that into the cloud, so you're having to push it back and work with the vendors at the edge. And then a lot about what John said, we were trying to look at images, and you're trying to process those, and depending on how fast your process is running, you don't have time to send that back. It's got to be done closer to where you need it. You know, if you're doing it for 4 or 5 wafers down the line, you might have time to do all of that. So that's going to be a hard question, because a lot of CIOs and a lot of people have put clouds in place telling everybody that's going to solve the problem. Now they're going to have to go back and say, looks like we may have to go back to more distributed. So to answer the other question, you know, the changes we saw is if you're putting robotics in, people see that really easy. Hey, I'm using some automation to move something. But if you're doing machine learning and some stuff behind the scenes, it's maybe improving quality in that, where the people didn't see it, it's really hard for them to get on board. What's the ROI? Is it really going to work? Can I trust this? You get a lot of, how do I know this is really going to work and not mess me up? So we had to spend a lot of time educating. And then there was one of the other questions, and then we had to train our workforce on understanding data. We had to build a whole system for training engineers to be what, I think the right term is data citizens. They're not data scientists, but they had to know a lot more than what they did know. And I know people get touchy about the terms, but we found that the thing that held us back was the people who know the tools and the data or what's going on in a process didn't really know how to manage all the data. So we had to spend a lot of time building that in.
Yeah, Jesus, I'd like to add one more thing to that, because building on that, the other question, I see there's another question that kind of aligns with this one coming from the audience as well, is the adoption and what things have to change. I actually see this kind of similar throughout manufacturing. I don't care if it's technology or adapting lean principles. I think you've got to look at what the philosophy of a company is relative to their ability to empower people to make local decisions based on data and based on their skill sets. So I think there's a big part of it that that how that gets adopted may vary. Just you could you could run successful companies different ways, but the more progressive companies are about relinquishing, there's going to be security issues, there's going to be mistakes, there's change is hard, and there's just a lot of it's kind of an age old, sometimes you don't really change till you're closing the doors. So it's just how how risk averse or how kind of forward thinking I think a company is as to what to suggest in that space. So it's just something I think this applies just like to other things we've done in the past relative to manufacturing change.
Yeah, and I think one other thing that we need to probably think about is the life cycle of some of the products that are being manufactured and what the lifespan is of Industry 4.0 and when we're going to go into 5.0 or 6.0. If you look historically, those years are being reduced every time we switch from 1.0 to 2.0. So that's also something that we have to think about, because we can't think about it that we install and do today is going to last 10 years. I think that time has passed.
That's a very excellent point too. Tony, what kind of facility changes have you seen in Europe that have called your attention?
Yeah, so regarding the Industry 4.0, the whole point is about the mass customization. So which means that you need to use this digital technology in order to provide this mass customization. And what is going on right now in Europe is a term backshoring. So the companies are not seeking or searching for low-cost production site outside of the Europe, but they would like to have their production companies near to their customers, which has a great influence on the supply chain. So, and the other thing about the Industry 4.0 is about the employment landscape. So the Industry 4.0 has been developed as well because of the shortage of the skilled workers in Europe, you know. And as you remember, in 2016, we were visiting a facility 4.0 in Karlsruhe, and you see that regarding the intra-logistics, you know, a lot of movement were produced or you know, by the AGVs, and the human or the workers were only the operating or scheduling those AGVs, which means that the level of knowledge that is required by the human worker is getting higher. So I should say that that the Industry 4.0, as I mentioned, you know, is highly oriented to this mass customization, and of course as well new business models. So new business models are as well an objective or necessary in Industry 4.0. And for example, I learned some papers recently that some companies in Europe are proposing only four working days per week and not 5 working days, you know, and in order to motivate their employees, you know, to spend more time with their families or to spend for their education, so that they will be more productive in this way. So so there is a lot of going on inside this Industry 4.0, as I mentioned, not just from the production side or the production view, as well as from the social view with these new business models.
Thank you, Tony. Fantastic. We have been discussing the human element a lot. So we have all these technologies that are developing in the manufacturing industries. And one of the questions that I often get is, what will happen to our labor? Will they disappear eventually as we automate the systems and we make them more intelligent? So what is your perspective on that? And also, if we want to keep our labor relevant, what kind of skills do we need to develop in the labor?
Okay, well, let me kick that one off. You know, it's our understanding that it requires a new breed of professionals. You know, we need to, and these professionals need to think in terms of processes and complexity levels, and they need to think about optimization. They need to understand, you know, the Lean Six Sigma theory of constraint principles, but they also have to be critical thinkers in problem solving, need to understand, as Michael just said, was it Michael? Data citizens, I think Michael, that was your statement, which is a correct statement. And they need to understand these data analytical principles. So we truly believe that the professionals that will be successful going forward have to be more rounded and not as detail oriented as some of these people are currently. Because there is too much that is happening inside the factory where these people work on a daily basis. I've also worked in the semiconductor industry, and if you look at what these people have to do on a daily basis, it's quite remarkable. And every time we go to a new level of technology implementation, it makes their job harder, and we need to make sure that we don't forget to train people. I don't think labor is going to go away. We just have to make sure that these people are growing and evolving, if you will, with the evolutionary process that smart manufacturing is going through currently.
Hey, I'd like to add.
Oh, go ahead.
Yeah, yeah, George here. I'd like to add to what Franco said. So you got, perhaps a, different breed of operators working in the smart factory. But one of the things that we have to think about is the in the institutions training engineers for understanding the human capabilities and limitations. I can tell you that I got my undergrad double E and master's in systems engineering, and I have to say that total time maybe for learning about the human element was maybe 5 hours. Okay, they want you to become, they want you to become the best hardware designer, the best software designer. But I can tell you that I've worked with enough with engineers over the years, that the philosophy is, well, I understand how it operates, so everybody else should. And that's really a bad assumption. And so I think we should be training engineers to think about the human element at the same level as hardware and software.
Yeah, I agree. You see that in other industries. If you, for example, look at the medical industry, you now have social workers that are in part of the hospital program here, at least in Austin, Texas, where we live. That they are combining, and they're doing the same thing. They understanding that the human element is crucially important. So yeah, I totally agree with George that it would be good for people to understand when you design something, that you truly understand who you're designing it for and what the environment is that it's going to be utilized in.
Yeah, I think you have to be, you kind of have to have that glass half full, that every time you're driving new technology and innovation, you're opening more doors than you're closing. So it definitely has a change kind of in the thought process at all different skill levels. It's not just, I don't think it's just saying that everybody has to be a higher skill level. It's just that it drives a change maybe in the thought process and how leadership drives to have everybody participating in that. I also think one other thing, building on the comment about schooling, and one of the things that people that like the panel here with so much experience, I could see happening that you want to try to avoid is, like, if you think of probably everybody that's attending this can look back and have some story about where my company spent hundreds of thousands, $1 million on some automation that was just never used. It just was, created a boat anchor. It wasn't done right, and it was all, really because not thinking through the overall process efficiency. I think you can do the same exact thing with AI and all the data, and start to, if you get people too focused, just look at any of the diagrams on 4.0. If you just get pocketed and focused into these pieces without really having an understanding of just the simplicity of trying to make a more efficient system, we could have all kinds of people and money spent in 4.0 and not get the benefit out of it. So you really, that also maybe goes back to consulting with companies that are reluctant. It's like, you can keep this really simple and just do some very basic things and be implementing AI. It could just be, one element of improving quality on a dock application or something like that. So, that's probably, to me, the best way to get started if somebody's reluctant, just to keep it simple.
I'll talk a little bit. I think one of the questions was, what are we going to do with some of the labor? And I think the challenge for companies is going to be, and I don't advocate laying off people, but as Industry 4.0 comes in and automation picks up and things improve, you're inherently going to need less people. And it's probably also going to be part of your ROI on some of this. So, we put in a lot of retraining, but one thing you have to look at as you go into this is, even if you retrain everybody, the most likely the end result of a good Industry 4.0 implementation is less labor. So what are we going to do with those, either within the company or other, move them out to other places or whatever? But I think people overlook that. I have people ask me a lot of times, well, what do you do with all the labor? Well, if you keep all the labor and you automate a lot of stuff, you better be growing really fast or doing something, or it's not going to work. So I sometimes get hit as kind of the downer on that, but that's a big part of this as you go in. You have to retrain your labor force. You have to skill them up in some cases, but you're also maybe going to have to find other opportunities for some level of your workforce.
I see that, exactly that. I see that as the big problem, the disimbalance of what's going to happen to the operator, right? And so I think we got a little bit of foreshadowing with this pandemic and the job losses that occurred based on how companies started to change their business model based on the current situations, or based on knowing that they can do exactly the same with less resources. And so I wish I had an answer. I mean, we all wish we had an answer, and I think this question has been posted through many conferences I've been through the last 5 years, and no one has had a clear answer. And what's gonna, I think, not just happen with manufacturing, but the decisions may not be relying on the CEOs or the presidents of the companies, but at some point, because it becomes a disimbalanced layoff of people's job losses throughout not just one country, but multiple countries, then you would probably feel that responsibility governments will have to pick it up. Now, the upside of this is that another foreshadowing that I noticed during this pandemic is that people are very creative, and they will generate different types of skills and jobs in order to deal with the changes of not just the situation with quarantine, but also with whatever changes we present technologically wise.
Yeah, I mean, also don't keep in mind at a macro level, as long as the technology keeps generating new business revenue streams. If you look back at all the companies that have been created and how many people they employ to service things that are in the cloud, that are helping all this work, all of the things that we're spending money on individually, just in services we get on our mobile phone and apps and things like that. You know, to me, as the technology advances, it's one thing to look at it with inside one company, you know, from a manufacturing perspective. It's another to look at it from all the ecosystem that kind of supports it, and see, you know, what the job situation is in an aggregate.
We have one question from our audience. Let me read this. When you think about competitive advantages in the manufacturing process, do you have any thoughts on how digitalization impacts cheaper, faster, better?
Yeah, I'll jump in on that one. So, yeah, to me, absolutely, because it goes to, you know, ultimately, you know, we've thought about, you got a high volume, low mix, low volume, high mix. You have your models that kind of are coordinate with that. I mean, ideally, you want complete customization at no price penalty. And I think once you speed up the data to be able to make changes, and you speed the technology to be able to adapt, and you're combining, you know, technologies that are designed into the product as well as processing it, you start to deliver, you know, more the ultimate of what the customer is looking for. And so that to me, and then the technologies, like I see you're talking about 3D printing and things like that. That's a great example of a technology that started, and it was pretty much for prototyping. And then it kind of moved into the advancement of 3D printing, where you could start to do mold tools and things like that. And you could do tooling and develop products a lot faster, to the point where it's just going to be able to, you know, print parts off of digital data in volume. So though a technology like that, you know, to me gets to where you get customization without a penalty ultimately.
Yeah. So what we saw, if you want to say faster or better too, is a lot of machine learning, a lot of sensors to predict equipment failures ahead of time. We've got it where, you know, we figured out you could predict a robot failure up to 6 months ahead of time, and then how much it was going to affect your product as you were continuing to use the robot. But what it meant was you could keep your tool up, you could maximize your flow, your output, and all of that until you wanted to schedule that tool to go down. So we saw a huge benefit in that, where you're running high volume very fast. And the other side where we spend a lot of time is just quality. If you're running really high volume and you're moving through, in the case of like semiconductor, you may be measuring every 1,000 wafer. Well, if you catch it on the second one, you've already processed 2,000 wafers that have some defect or damage to them. So if we can pull this back where you can even get it down to every 100 or every 25 and stop the equipment, you're improving your quality. You're making it faster because you're not going to have to make up for that damaged product you did. So we see huge advantages in making it faster. Better control of your line, better planning of your equipment maintenance, predictability of your equipment maintenance, and better control of quality.
Yeah, I agree. And when you get to full digitalization and with the current compute power that is available, which was not available 5 years ago, AI is a lot more powerful, and you could almost make real-time decisions on changes that we have to make. And a full digitalization process is also where you tie the designers to the manufacturing people and back. Right, so those two now should be living in the same reality in terms of data, and make sure that we are not just collecting data, but because a lot of companies are still data rich and information poor, but close that loop. And then secondly, to the 3D printing, I believe that 3D printing is going to change long term and create a lot more decentralized manufacturing.
Thank you. One of the situations, Damian, is the data, right? The data cost, the cost of maintaining the data, cleaning the data, and then training the machine learning artificial intelligence. And a lot of times that comes with some bias, and the results could be impacted. So what are your thoughts on this?
Well, the overall generalization of data, definitely, yes, you can introduce biasing to your applications. And I think the advantage of manufacturing is that we can control all the parameters and the environments in the manufacturing space, where we can have deterministic systems, where we can be biased on purpose. Right, the advantage that manufacturing has over space, like George mentioned, is the deterministic variables that we have and that we can control, and more importantly, that we can explain. Right, so the data definitely will bring that explanation to the domain, and it will definitely help achieve more refined machine learning and AI implementations. Now, data itself, it will take a long time, right? Because if you've ever done practical machine learning implementation for production, any data scientist will tell you that 90% of the project was spent just looking at the numbers. Because training or coding the machine learning takes about 10 minutes. And the training of the model can take days or weeks or months, depending on the volume. And so the effort is the recognition in how the data can answer the questions that you need. And knowing that the sheer volume of data, or maintaining or curating the data, is exactly having the right people looking at the data with the domain in which the data came from, understand the processing which generated the type of data in order to have the right outcomes and biasings that you want in your manufacturing plants. And so the goal here with AI is that we have to have a good deterministic features that will help deal with the data, and dealing with all that, it's an infrastructure problem too, because we can tie in our ROIs to it. We can implement the human aspect to this. It's an infrastructure problem also when it comes to machine learning. And so implementing AI doesn't mean that you can just quickly do this. It's going to require its own planning, and it has to require its own designing approach, even if it's in semiconductors or some kind of robotic automation process itself. And it's a cost, and it's a thing that it's going to require a lot of effort and possibly a lot of time to implement as well.
In Industry 4.0, we have discussed, there's a lot of technology. We have discussed artificial intelligence, 3D printing, Internet of Things, robotics, and there's a lot of technologies. So for those participants in the audience that follow us, and they want to start their journey on Industry 4.0 smart manufacturing, where should they start? Where should be their first priorities in order to enable Industry 4.0?
I always like to talk about where the company is currently, where they ultimately want to go. So let's assume that that's an ideal state, and then identify what the current state is, and then figure out the balance between improving and training your people, updating your processes and your technology. And I think John said it earlier, you don't have to go all out. Keep it simple. So that would be my advice.
I agree. I also think to build upon that, you look at maybe it's identifying, kind of think of it as mapping out where there's the pain points or opportunities. Because when we talk about the digitization, the AI, and the connectivity, to me, you link the product and the process together. So, if the opportunity is more about how to develop a product better, how to penetrate the market, how to get that, you can start to focus the information on closing the loop of data coming off of a product, especially if it's a product that generates data and communicates back into the development process. If the business is different and it's more about, where your cost is in your process and work in process and yield or whatever it might be, and may shift it more towards the process side of it. But I think, so it could vary just depending on, where the opportunities are. So it takes you back to being able to do, a complete analysis of your value, value add, non-value add, kind of like a process mapping from your development all the way through to the end, and mapping that out.
So one thing I'll add a little bit, and we've talked about it a lot. One, you have to really start some basics of what data do you have if you're trying to solve some problems. Do you even have it? Do you understand it? What we learned was one, we had a lot, and most of it wasn't any good. We had a hard problem, and I see a lot of companies put together really big plans, and they just have a hard time getting started. So to John's point, we ended up just picking our biggest pain point and worked on that. Said, hey, can we understand this enough that we can make a difference? And we figured out how to do it, and it actually worked. Unusual for one of the first ones to work, but once it worked, then it picked up some momentum too, because you had other people looking at it saying, hey, I have a similar problem. Can I do the same things? And so we kind of chopped out a little bit with an idea of where we were trying to go, but we had a hard time defining what that really was to us. So pick a few things intermediate that you think you can do and get started. What I hear the biggest problem with a lot of companies in Industry 4.0 smart factories is actually getting started. A lot of them have made plans, but they don't ever execute because there's always something that holds them back. So figure out how to execute at least one project and see what happens.
Yeah, the other advantage, if you do what Michael says, is that you would see benefits real quickly, and then you could you have a pretty good ROI, which then allows you to fund follow-up projects. And now the CFO is spending money that he currently doesn't have. So the whole process makes it a lot more attractive from a financial perspective if you go about doing it like that.
And if, it could be accelerated now too, building off what Tony said in Germany, and I think this is going to be a lot of places looking at re-engineering the supply chain and onshoring things. The given state of what's going on could be just a catalyst to help drive this, because once you start to look at everything we're talking about, after spending almost 20 years of Flextronics all over the world manufacturing for other people, there for sure are extra challenges when your process is broken with all different companies, and you're fabless, and you're not doing manufacturing, or, so back in the day when my first jobs were all completely vertical companies doing everything. And, that evolved to outsourcing, and now I can see that swinging back and being able to take this opportunity to start to map out, that change in the way you look at an ROI. And it's all based on, comes back to the ability to make decisions really quickly.
Thank you, everyone. I think we have opportunity for closing comments, so we can go around the panel. Perhaps you can throw in some comments on how COVID-19 pandemic will change, manufacturing overall. So let's start with Michael.
Thanks. I see one question out there I'll talk to real quick on augmented reality and the role. So what we were looking at was for training. Can I do basic like a PM through augmented reality? And then as I bring in, for instance, a new technician, I just put them in an augmented reality program to teach them how to do the PM or the work, and I don't have to assign a senior engineer. So we were working on that. The other thing we were going to look at where I think augmented reality may come in really handy is we can't work on all the equipment that's in a semiconductor factory, and you have to go to next level support. So if we figure out a way to tie those vendors and all that in with somebody at the tool, maybe with some augmented reality type glasses, we can probably work something out there. We hadn't figured out anybody to do it with, but I see that something in the future. As far as COVID-19, semiconductors already pretty automated, so the factory will run. It may not run good because sometimes things can go wrong. So the challenge is going to be, what are those jobs that are really important? I think Damian said earlier, if you're used to having 3,000 people on site and all of a sudden you're running with 2,000 people on site and nothing's changed, I think next year a lot of people are going to be sitting down going, what happened? How did I do that? Or did I miss something? People working from home. Right.
Thank you, Michael. Franco?
Yeah, regarding augmented reality, I think I've seen some solutions where you do remote assistance. Michael said it. You don't have to send your most valuable assets around the country or around the city. You could have that person be valuable and coach and train multiple technicians. The other place is maintenance. Have instruction ready to go on the person's AR glasses. So that's where I see the role of AR in smart factories. And you can even do it with processes, right? You could even augmented reality overlay your work instructions, especially for younger people, for them to become effective faster. COVID-19, I sadly enough, I was in New York on Long Island during 9/11, and they were building office space like crazy because there was never enough. And then those two towers came down and there was still plenty of space. I think that's going to happen with the workforce. The other thing is that a lot of executives were very hesitant to do video conferencing because it was never going to work. And here we are with a panel with 30 plus people on the call, and everybody gets the point across. I don't see. We're a relatively small company, but we have people on either coast. And before it was all video call, no, not video call, was conference call. And now we're doing video calls all the time. So we have become closer as an organization. The only problem that I have as a parent is that I've tried my whole life to get my kids off the screen, and now I have to push it back on the screen because that's what the school is doing. But that's a whole different conversation. But I think somebody said it earlier. So human beings are extremely creative, and they will. And I think it was John, if I'm not mistaken. I think we as a society and as a human race are going to find a way to be productive. Because we can't stop ourselves even for trying. So I see a very bright future, and I see COVID-19 as just another way for us to drive ourselves to do business differently because we have to. So,
thank you very much, John.
All right, I'll start with augmented reality, virtual reality too, just to see the question there. To me, both I think Michael mentioned training. I see the virtual reality more of a training tool, a little bit separated, but I think augmented or mixed reality is an execution tool and an efficiency opportunity. I think one of the things that's going to be required is some standardization. You know, it's a difference. You know, I've looked at this type of technology in the construction space when we talk about building information modeling and buildings and be able to see through a wall, things like that. Same thing would be, you know, if I'm going to go out to the factory floor, I'm a maintenance person. Well, whatever piece of equipment, I ideally want to just be able to look at it, and you know, the diagrams, schematic, and things are coming up. So you're going to have to get some standardization in how companies manufacture, produce all these things that you're looking to use it for. There's other use cases that you can control within your environment. You know, like if you're using AR for a heads up in a warehousing, you know, pick situation, things like that. But I think those are got real practical use cases. And so as the technology advances and wearables and things like that, they just become more and more common. You know, regarding COVID, you know, it was funny because I can't tell you how many times I've sat on a trip in a factory in Asia or Europe or somewhere, and a day into it, sitting there working, going, I could have completely just done this at home. So I think that there's a need to be face to face and to collaborate, but there's just a lot of inefficiency around traveling, around getting things done. So, you know, if anything, this is just forcing, like I said, the acceptance of digital communications and technologies even more mainstream. So it could help just, you know, accelerate that process.
Thank you, John. Tony?
Yeah, I think that Industry 4.0 will evolve further to the Industry 5.0, so where everything inside the manufacturing will be digitalized. And yes, as for warehousing, I think that the future trend will be the peak supporting AGVs, because most of the warehousing order picking operation is still manual. So I think this will be some option to automate the processes and integrated systems as well. Human-machine interaction is very important, and as well here we need some standardizations, and of course as well warehouse sustainability. So in Europe there is a lot of going on about lower CO2 emission or carbon footprint and energy consumption. Yeah. And regarding the COVID, yeah, the COVID has affected quite a lot the supply chain. And this is why some companies in Europe have started to thinking about this backshoring, so that because of mass customization and in order to place the production near to the final customer. So there is a lot of debate about this issue about backshoring. Yes.
Thank you, Tony, and thank you for joining us from Slovenia. We appreciate it.
Yes, thank you.
Damian?
So in the comments of augmented reality, yes, I think it's definitely going to pick up in not just manufacturing, but in all sectors. I think, you know, being able to construct digital twins of any kind will definitely drive the need for augmented reality or mixed reality interactions. And I think NASA, like Industry 4.0, will take advantage of those technologies as we get cheaper, faster, and better at everything. And it's just common sense. And I think that's going to impact the way we do education at the university. I think younger generations of students will demand such things to be present in the classrooms and be able to go to class from your bedroom and yet still have the virtual classroom experience. And why go to school when you can just do it from home and be stuck either on a screen or on a VR, AR glasses, right? And interact that way and still learn engineering in such a way. And as far as COVID, my immediate reaction of that is, it's an example I had last night in my machine learning class. I was approached by a graduate student and admittedly got laid off because of COVID from Intel, chip designer. And I got schooled trying to learn machine learning, because the student figured out that this is probably the way they can reconfigure themselves in a way that it won't happen again to them. And I think the realization of the retraining, re-education, migration because of this, many schools will see it in the upcoming year.
Thank you, Damian. So we had also an amazing keynote speaker today, and I just wanted to thank him for that. And do you have any closing comments, George?
I just want to say it was an honor to be part of this esteemed panel, and I totally enjoyed the interaction, the questions, and I learned quite a few things today. So I'm very appreciative of that. So thanks for having me.
Well, this is all for today for us. Thank you very much to all the panelists and all their excellent contributions, and also thank you for to Andres for the opportunity to present this important topic to the community. And finally, here at Texas State, we're very happy to have these types of collaboration with industry, and we look forward to look for continued work with you. So Andres,
Congratulations, guys. Thank you for everything. Really, kudos, exciting panel, great conversation. Let me stop recording, and we can relax for a few moments as people leave the room. I'm going to stop recording now.